set that white balance thing. All right, so here we go. So we write this. This is going to have some long names to it, but it's no big deal. And take it away as acetyl-Coenzyme A. And what you're going to be left with are 2 of these sulfurs with H's on them. So let's color these in. As we came across, the acyl group is now on our lipoic acid. That's why this is such an essential nutrient here. This is 2 sulfurs of lipoic acid. Now you've got it acetylated. This is the 2 carbon from the pyruvate that came from the glucose that you ate. Then acetyl-Coenzyme A is going to take that away to the citric acid cycle. So, but look at this enzyme again. See how long that is? And it acts like an arm. It goes up to Pyruvate DeHydrogenase, grabs the acyl group, is actually pushed off this because of the electron density. So it gets protonated on the anyway. So here we go. These carbons coming up are just CH2s. So they're red. CH2 scarlet. CH1 is brown. So what we're going to end up with is the sulfur up there with the acyl group. These guys are back, so we can just copy this part. Just copy it verbatim over here. So watch what we'll do. We'll just take our 3 diamonds in a row, right? 1, 2, 3. Put your H's on there if you want. Just exactly like it looks over here. Right there. Right here. So you go. Back it up a little so we get all that on there. So 1, 2, 1, 1, 2. This will come down there. We don't really care. So look, there's 1 bond left on those. That's where it goes to the sulfurs. So sulfur we're using green because we need something dark to show up. And green just happens to be the oxygen's colors family. Losing my pens here. So just draw the tip of the Star David there. So that's 1 sulfur. 2 sulfurs. Like oxygen, if it needs 1 more because it's got 2, just put 1 on there. So these are still electron pairs if you wanted to think of it like that. There's 1 alien, right? Another alien. Like oxygen. So you see the way these similar electron configurations allow for the same types of reactions as the elements in the groups above them. But this just amazes me. If you can picture this arm going to 1 enzyme, grabbing 2 carbons off, going over, giving it to acetyl-Coenzyme A, then going over here and having another enzyme take the H's away so that the arm can go back over here and do the thing all over again. I mean, it's like a little conveyor belt. It's really cool. So color these in again. We need scarlet for the CH2s. And we need brown for the CH1. Sulfurs are yellow. There's our highlighter here, just kind of. So this again, RiboFlavin, vitamin B2. RiboFlavin has to take these H's. So do you see the way we got this drawn here? Let's try it out here. We'll just draw the benzene ring for short here. So how do we do benzene ring in short notation? We know there's an H on each of those. And they should be CH1s. So we took the brown, did the circle, and then we took the yellow to show that it was aromatic. Now these go to N's. So here's a N. There's an N. Make them right angles. Now this N is going to go double bound to a carbon. But what we're going to do is we're going to take this H and bring it to there. So that's going to make a single bond to a carbon. That N is still a single bond to a carbon. So make these two carbons there. What we end up with is an N on this. Goes to a diamond with a double bound O on it, which goes to an N, which goes to a carbon with a double bonded So now when you see this ring here, one proton went there, the other proton's going to go over on this side. So let's draw maybe an empty red. How about that? That work? Empty red one there. Color in the green. So lots happening here. That's why when you color it in, focus more on exactly what's happening. That'll go back to make this a ring. 2 H's gone. End up with an NH here. This end here goes off to the enzyme, so that's taken care of. You can color those in. So a double bond left here to allow that proton to go on. The double bond moved down here. Should be in the middle. So we're just going to have to draw that end to end. Color those in a little bit if you want. Schroeder diamond, Schroeder diamond. That end's taken care of with the